So yesterday we looked at the concept of an imaginary number. Today we're going to look at doing operations with complex numbers. Let's start with the warm-up. Find the zeros of y equals x squared plus 4x plus 5. Remember other terms or words for zeros. You're looking for the x-intercepts. They're also called the roots, and again the zeros. So first step, we have x squared plus 4x plus 5. Some of you can solve by guess and check. I like putting it in the box and circle. So we have x squared, 4x, and 5. And we want to know what multiplies to the first and the last number. So multiplies to 5x squared. That adds to 4x. So some factors of 5 are 1 and 5, and that's it because 5 is prime. And we want them to multiply to 5 and add to 4. So again, we have 1 and 5. Now there's no way that we can put a negative here because then it won't multiply to negative 5. And it will not add up to 4. So here, box and circle will not work. So we're going to have to use quadratic formula. So let's erase this guy right here. Let's use quadratic formula. First up, identify A, B, and C. A equals 1, B equals 4, C equals 5. All right, let's plug in. X equals opposite B plus or minus the square root of b squared minus 4ac all over 2a. All right, so there's how we plug in. Remember to calculate these three numbers right here. So we get negative 4 plus or minus the square root, and that ends up being negative 4 over 2. So yesterday we learned if you have a negative inside the radical, you're going to pull that out as an I, and then we can take the square root. So negative 4 plus or minus the square root of 4i over 2. I'll rewrite that as negative 4 plus or minus 2i over 2. And then we'll break it up even further, and we can divide each of these terms by 2 right here. So we get negative 2 plus or minus I. And again, if you want to write the two roots, that's negative 2 plus I and negative 2 minus I. So we can break that up. And those are the two imaginary roots. Our goal today is to deepen our understanding of complex numbers and do mathematical operations with them. I think there's a video that you can watch with Intro to Imaginary Numbers, but I think for the podcast we'll just go over the difference between imaginary and complex numbers. So I'm going to erase this. Okay, and a complex number has a real part and an imaginary part, so here's what it looks like, a plus bi. So here's the complex part. It has your real number first, and it has your imaginary number second. And again, watch the video in class on what that looks like, but this is a complex number. It has real and imaginary numbers. And so you might be asking, whoops, I didn't mean to do that. You might be asking, where does that fit in the whole scheme of numbers? And so we have this tree diagram that shows us where are these complex numbers in relation to all other numbers. So if I label these, this first set of numbers right here, these are called natural numbers. Natural numbers were the numbers that they used before they developed negative numbers and 0. So those are natural numbers. If you include negative numbers and 0, these are called integers. I'm going to change color here, sorry. Integers. And then we have rational numbers. Rational numbers are any numbers that can be written as a fraction. Rational. Irrational numbers are any number that you can't write as a fraction. They could be like pi, goes on forever. There's no pattern, no repetition. You can't write it as a fraction, so those are irrational numbers. And then we get into the real and imaginary. So we have real numbers. Real numbers can be rational or irrational, so these are real. But then if they have an I in it, these are called imaginary numbers. And then if it has a real and imaginary part, these are complex numbers. Okay, so here's where they all fit in the scheme of things. Today we're just looking at operations with complex numbers. Remember, I is the square root of negative 1, and therefore I squared is negative 1. So the first one, let's add. And it's just like combining like terms here, so I'm going to add my real numbers first. We have 14. I'll add together the imaginary numbers. So negative 7 plus 6 is minus I. So there's the first answer. The negative 1, again, we're combining like terms, but remember, if there's this negative right here, it's like a negative 1. You have to distribute that. So let's distribute the negative 1. And we'll get 7 minus 12 plus 8i. And again, add your real numbers together. 7 minus 12 is negative 5. So you get negative 5 plus 8i. All right, this one has a few operations we're going to distribute. So we get 52 plus 12i, and then you have that plus 6i hanging out at the end. And again, you'll combine like terms. We get 52 plus 18i. So it's just like combining like terms, except you have your I there. Let's do one more like this. So again, we got to distribute. We'll get 6 plus 4i. Distribute this negative. So minus 5 plus 6i. And then again, you add together your real numbers and your imaginary numbers. So 6 minus 5 is 1. 4 plus 6 is 10. So 1 plus 10i. All right, so that's adding, subtracting, combining like terms, distributing. All right, the last type of problem, we're going to multiply these. So think back to when we multiplied binomials and trinomials. You can either distribute every number. I like the box, though, so I'm going to stick this in the box. We got 2 minus 3i. We have 4 plus 7i. And we're going to multiply, and we're going to find each term. So 4 times 2 is 8. 4 times negative 3 is negative 12i. 2 times 7i is 14i. And negative 3 times 7 is negative 21i squared. Now the only difference with this type of problem is when you see an I squared, remember I squared equals that negative 1. So when I write this out, we'll have 8. This right here is negative 21 times negative 1, so this is 21. So plus 21 minus 12i plus 14i. So I'm going to add together the real part and the imaginary part. So we'll get 29 plus 2i. Okay, so again, when you're multiplying, be careful when you get the I squared, it equals negative 1. Turns into a real number. All right, the last one is 7 plus 3i times 7 plus 3i. Okay, so again, we'll multiply, get the inside the box. We got 49, 21i, 21i, and 9i squared. Remember, your I squared is a negative 1, so 9 times negative 1 is negative 9 right here. Combine like terms. 49 minus 9 is 40. We'll add together 21i plus 21i, so you have 42i. And there's your final answer. Okay, so today you're going to practice these ideas, and tomorrow we'll go over any questions that you have. Thank you. All right, so we have day 11 operations.